In the vast expanse of our solar system, Venus, our closest planetary neighbor, has always been shrouded in mystery. This enigmatic planet, often referred to as Earth's twin due to its similar size and composition, has intrigued scientists and astronomers for centuries. Hidden beneath a thick veil of clouds, its surface remained hidden from view. The dense atmosphere, composed mainly of carbon dioxide, with clouds of sulfuric acid, made it nearly impossible to see what lay beneath. In 1989, NASA embarked on an ambitious mission to unveil the secrets of this enigmatic world, the Magellan mission. This mission was a significant leap in our quest to understand the planets in our solar system. Named after the famed Portuguese explorer Ferdinand Magellan, the Magellan spacecraft was launched on May 4, 1989, aboard the space shuttle Atlantis. The launch was a momentous occasion, marking the beginning of a journey that would take humanity closer to understanding Venus. It embarked on a 15-month journey to reach its destination, Venus. The spacecraft traveled millions of miles through the vastness of space, navigating the challenges of interplanetary travel. Magellan carried a suite of sophisticated instruments designed to pierce through the planet's dense atmosphere and map its surface in unprecedented detail. These instruments included a synthetic aperture radar, which was crucial for penetrating the thick clouds and providing high-resolution images of the surface. The mission promised to revolutionize our understanding of this mysterious world. By mapping over 98% of Venus's surface, Magellan provided invaluable data that would help scientists study the planet's geology, including its mountains, valleys, and volcanic activity. The spacecraft arrived at Venus on August 10, 1990, and began its intricate dance around the planet, using radar to see through the thick clouds and unveil the secrets hidden beneath. This mission marked a new era in planetary exploration, shedding light on one of the most mysterious planets in our solar system. The Magellan mission had several key goals. First and foremost, scientists wanted to create a detailed global map of Venus's surface. They were eager to understand the planet's geology, including its mountains, valleys, and plains. Another crucial objective was to study the planet's atmosphere, which is much denser and hotter than Earth's. Magellan would help researchers understand the composition and dynamics of this extreme atmosphere. Finally, the mission aimed to investigate Venus's gravity field, providing insights into the planet's internal structure and evolution. By achieving these goals, Magellan promised to unlock many of Venus's long-held secrets. Venus's thick atmosphere, composed primarily of carbon dioxide, prevents direct observation of its surface using visible light. These dense clouds are so thick that they reflect and scatter sunlight, making it impossible for traditional telescopes to see through them. The surface remains hidden beneath this impenetrable veil, challenging scientists who wish to study the planet's geology and topography. To overcome this significant obstacle, the Magellan spacecraft was equipped with a powerful radar system. This advanced technology was specifically designed to penetrate the thick clouds and provide a clear view of the surface below. The radar system was a crucial component of the mission, enabling scientists to gather data that would otherwise be inaccessible. Radar works by sending out radio waves and then listening for the echoes that bounce back when they hit a surface. These radio waves can travel through the dense atmosphere of Venus, reaching the ground and reflecting back to the spacecraft. By measuring the time it takes for the echoes to return and analyzing their strength, scientists can determine the distance and characteristics of the surface features. By analyzing the time it took for the echoes to return and their strength, Magellan could create detailed images of Venus's surface, even through the thick clouds. This data was processed to produce high-resolution maps, revealing the planet's mountains, valleys, and volcanic plains. The radar images provided unprecedented insights into the geological processes shaping Venus. This technique, called synthetic aperture radar, or SAR, allowed Magellan to map the planet with remarkable clarity, revealing features as small as a football field. SAR technology synthesizes the data from multiple radar signals to create a comprehensive and detailed image. This method was instrumental in uncovering the hidden landscape of Venus, offering a new perspective on one of our closest planetary neighbors. As Magellan orbited Venus, its radar system diligently scanned the planet's surface strip by strip, revealing details that had been hidden beneath the thick, toxic clouds for eons. Building up a comprehensive picture, the images that were beamed back to Earth were breathtaking, offering an unprecedented glimpse into the planet's mysterious landscape. They revealed a world sculpted by intense volcanic activity, with vast plains, towering mountains, and features that spoke of a dynamic geological history and intricate networks of canyons and valleys. These formations suggested that Venus had been geologically active for much of its history. The surface of Venus turned out to be surprisingly young, geologically speaking, with many areas showing signs of recent volcanic activity. Scientists estimated that most of the planet's surface had been reshaped by volcanic eruptions within the last 500 million years, a relatively short period in planetary terms. This was a stark contrast to the ancient, heavily cratered surfaces of planets like Mars and Mercury, which have remained largely unchanged for billions of years. Venus, with its youthful and ever-changing surface, continues to intrigue scientists and challenge our understanding of planetary evolution. One of the most striking discoveries made by Magellan was the sheer abundance of volcanoes on Venus. The planet was littered with volcanic features of all shapes and sizes, from small shield volcanoes to massive calderas, some spanning hundreds of kilometers. Magellan's radar images revealed vast volcanic plains formed by massive outpourings of lava. These plains covered much of Venus's surface, attesting to the planet's violent past. Among these plains were intriguing features known as pancake domes. These dome-shaped structures, with their flat tops and steep sides, were unlike anything seen elsewhere in the solar system. Perhaps the most intriguing discovery made by Magellan was evidence of recent volcanic activity on Venus. By comparing images taken during different orbits, scientists discovered several areas where the radar reflectivity of the surface had changed. These changes, they believed, were most likely caused by new lava flows that had erupted between Magellan's first and second mapping cycles, which occurred between 1990 and 1992. This finding was significant because it suggested that Venus was not a geologically dead world, as some had thought. Instead, it appeared that volcanoes were still actively shaping its surface. After 4 years in orbit around Venus, Magellan had far exceeded its original mission goals. It had mapped over 98% of the planet's surface, providing an unprecedented view of this enigmatic world. However, the spacecraft was nearing the end of its operational life. Its fuel supply was dwindling, and its solar panels were beginning to degrade. On October 12, 1994, controllers at NASA's Jet Propulsion Laboratory commanded Magellan to perform a final maneuver. The spacecraft dipped into Venus's atmosphere, where it burned up, bringing its remarkable mission to a close. The Magellan mission revolutionized our understanding of Venus. Its detailed radar maps revealed a world more complex and dynamic than anyone had imagined. The discovery of widespread volcanic activity challenged previous assumptions about the planet's evolution. Magellan's data provided scientists with a wealth of information to study for years to come, and it continues to shape our understanding of Venus today. The mission demonstrated the power of radar imaging for exploring planets shrouded in thick atmospheres, paving the way for future missions to Venus and other worlds. The Magellan mission left an indelible mark on planetary exploration, inspiring a new generation of scientists and engineers. Its discoveries have fueled a renewed interest in Venus and its mysteries. Today, several space agencies are planning new missions to Venus, equipped with even more advanced instruments than Magellan. These missions will build on Magellan's legacy, seeking to answer fundamental questions about Venus's atmosphere, climate, and potential for past or even present life. The Magellan mission may be over, but its journey of discovery continues to inspire us to explore the unknown and unravel the secrets of our celestial neighbors.